solved the same problem, I guess, with two different methods, but it came out to be a consistent system each time, which is really sort of what we expect. Let's take a look at this particular problem and see what happens. We can use, if you'd like, get rid of the x, I guess, and so we'll multiply by a -2 and get -4x minus 2y equals a -10. So this one we'll just leave alone. 4x plus 2y equals 8. Now, we get a 0 here, but we get a 0 here also. And that equals -2. Well, does 0 ever equal -2? No. Therefore, we'd have to say, you know what? I cannot find any x or y value that will make this a true statement. This is inconsistent. Those are the parallel lines we talked about. And it makes sense because we get sort of the same slope from this stuff, but a different y-intercept. Let's solve this for y. Subtract 2x from both sides. So when y gets a -2x plus 5. Let's solve this one for y. Let's see, 2y equals a -4x plus 8. Or, dividing everybody by 2, we get y equals a -2x plus 4. So these two are almost the same, except they have a different y-intercept. Inconsistent. Parallel lines never cross. Suppose we had 2x plus y equals 4 and a -6x minus 3y equals a -12. Well, let's do sort of the same. Let's solve for y here. We use substitution. Y is equal to a -2x plus 4. Let's plug that in for this y. -6x minus 3 times -2x plus 4 equals a -12. -6x plus 6x minus 12 equals a -12. Well, these cancel, and if you add 12 to both sides, you get 0 equals 0, or -12. Well, that's always true. Well, if something's always true, then it's really the same line. And if you look at these, you can maybe see that. Let's multiply the top one by a -3. We get a -6. Oh, I take that back. But this should be the same line. Yeah, times a -3. -6 minus 3y minus 12. It's the same as that line down here. So, if you get something that's always true, this is a dependent system. If you get something that's never true, it's inconsistent. If you get that one point where you find a true spot, then this is a consistent system. This is what we're looking for. But these can happen, certainly. Okay, next are matrices.